In this lesson, we are going to learn how to find the equations of a plane. So from this figure that I have here, okay, I have this plane here, and then I have the normal vector n, which is orthogonal to the plane, and then I have 2 points on the plane, which is point P and then point Q. Okay, so from this figure here, okay, if I were to generate a vector on this plane here, which I name vector PQ, this vector will be orthogonal to the normal vector. Okay, so what then will happen is that if I take the dot product of this new vector that I have generated and that of the normal vector n, that will be equal to 0. So I'm going to use this idea to generate the formula or the expression for the equation of a plane. So I'm going to generate a vector. Okay, I'm going to generate a vector using these 2 points on the plane, which is this point P and then Q. Now I'm going to name this vector as vector PQ. Okay, I'm going to name this vector as vector PQ, and then we have the normal vector n. So let's take the point P. Okay, let's take the point P to be equal to x naught, y naught, z naught. Okay, and let's take point Q to be equal to x, y, z, and then the normal vector n will be equal to a, b, and then c. Okay, so we know all these values here. Okay, so let's try and then generate vector pq. Okay, so from there we are going to have vector pq, okay, to be equal to x, y, z, okay, minus x naught, y naught, z naught. Okay, so we can further write vector pq as x minus x naught, comma, y minus y naught, comma, z minus z naught. Okay, so this will be our vector pq. Okay, and since vector pq is orthogonal to the normal vector, when you take the dot product of these two vectors, that will be 0. So we are going to have the dot product of the normal vector n and that of vector pq to be equal to 0. Okay, so let's do the substitutions here. We have the normal vector to have components a, b, and c. Okay, and then that will be multiplying the vector pq, okay, which will have to be x minus x naught, comma, y minus y naught, comma, z minus z naught. Okay, and this should be equal to what? 0. Okay, this equation here, which I'll name as equation 1, is known as the vector equation of a plane. Okay, this is the vector equation of a plane. Okay, I can write this as a multiplying x minus x naught, okay, plus b multiplying y minus y naught, okay, plus c multiplying z minus z naught. Okay, this will be equal to 0. This is equation 2. Okay, we call this the scalar equation of a plane. This is vector equation of a plane. Okay, and then what you have here is the scalar equation of a plane. Okay, so with the scalar equation of a plane, I can further simplify this. So let's distribute the components of the normal vectors. So I'm going to have ax minus ax naught, right, plus by minus by naught plus cz minus cz naught. Okay, this should be equal to 0. So we are going to group the we are going to group terms here. Okay, so look at what I'll do here. This will give me ax plus by plus cz, okay, plus cz minus ax naught minus by naught minus cz naught. This should be equal to 0. Okay, so what I'll do is that I'll consider all these three terms here, okay, and then equate them to d. Okay, so I'm going to have minus ax naught minus by naught minus cz naught to be equal to d. So I'm going to have this to be ax plus by plus cz plus d equals what? 0. Okay, this is sometimes known as the general form of the equation of a plane. So we know the vector equation of a plane and then the scalar equation of a plane. Okay, so with this idea, we are going to take an example. So let's go ahead and then look at that. Okay, so we have this example here, which says that we should write an equation for the plane containing these 3 points given here. Okay, so in this case, you've been given 3 points on the plane. Okay, and then you have to write an equation for the plane. So what we need here is that we will need the normal vector. Okay, which is the normal, sorry, which is the vector perpendicular to the plane. Okay, so how are you going to find this normal vector here? Because when you look at equation 2 here, okay, when you know the normal vector, then you can write the equation of the plane, because you can use any of these given points here as x naught, y naught, and then z naught. Okay, so all you have to do here now is to find the normal vector. Okay, so our main focus will now be on finding the normal vector of the plane. So how do you find the normal vector of the plane? The normal vector of a plane, okay, could be is given by, sorry, the normal vector of a plane is given by the cross product of two vectors in that plane. Okay, so if I have a plane and then we have some point on that plane, okay, and then I want to find the normal vector for that plane, I can just consider any vector on the plane. Okay, I'll consider two vectors on that plane and then I'll take the cross product of those two vectors, and then that will give me the normal vector or the vector orthogonal to that plane. Okay, so we have these 3 points here on the plane. Okay, so what I'll do is that I'm going to generate vectors from these points given, and then I'll take the cross product of any two of those vectors. Okay, so from this point that I'm giving, okay, I can form vector PQ, okay, from this point, and then I can also form vector QR. Okay, depending on the vector that you want to form, okay, you just have to make sure that you form two vectors from the point given on the plane, and then you find the cross product of these two vectors, and that will give you the normal vector. So I have vector PQ and then vector QR from this points given here. Okay, so now let's find vector PQ. Okay, so vector PQ. Okay, so for vector PQ, I'm going to have 0 minus 1, comma, I'm considering point P and then point Q, okay, comma, 2 minus 1, okay, and then comma, 1 minus 2, okay, this is what you have now. So simplifying PQ, we are going to have minus 1, 1, and then 3, okay, because you are going to have 1 plus 2. So now let's look at vector QR also. So for vector QR, that will be minus 1 minus 0, okay, comma, then you have minus 1 minus 2, and then comma, you have 0 minus 1. Okay, so let's simplify vector QR. So simplifying vector qr, I'm going to have -1 comma -3 and then -1. So this will be vector qr. Okay, so in this case, our n, which is the normal vector, will be equal to the cross product of these two vectors which are on the plane. Okay, so that will be the cross product of vector pq and then vector qr. Okay, so what you have to do now is to find the cross product of these two vectors, and then we are going to do this using the determinant approach. Okay, so let's look at that. So this will be equal to, I have I, j, and then k here. Okay, so let's write vector pq. We're going to have -1, 1, and then 3, and then for vector qr we are going to have -1, -3, and then -1. Okay, this is what you have now. So now let's compute this and then get the component of the normal vector. Okay, so let's look at that. So I have this bracket here. Okay, then I'll bring my I here. So I'm going to have 1 multiplying -1. Okay, I'm considering what you have here. Okay, so that will be 1 multiplying -1, and that will give me -1. So that will be -1 minus 3 times -3, that will give me -9. So that will give us +9. So I'm going to have -1 plus 9i. Okay, then let's continue. So -j. Okay, then let me clean this from here. Okay, so -j. So considering j, you're going to have -1 multiplying -1, then that gives us 1, and then 3 multiplying -3, so that brought -3. So you're going to have +3. Okay, so you're going to have +3 here. So I already have the j there, so let's leave it. Okay, I think since I brought the I at the back, let me remove this j from here and then bring it here. Okay, so you have the j here. Okay, so plus, then we are considering the k direction. Okay, so we are going to have -1, okay, multiplying -3, and then that's going to give us a value of 3. Okay, and then we are going to have 1 multiplying -1, that gives us -1. Then because we are going to subtract, we are going to have +1. Okay, so that's +1k. So let's simplify this. This is going to give us 8i minus 4j and then plus 4k. So this will be the normal vector. So I can write this as n equals 8 minus 4 and then 4. Okay, so we have the normal vector now. So now what you have to do is to consider any of the points here. Okay, so we are going to consider any of the points given. In this case, I'm going to consider the point P. Okay, so let me write point P here, which is 1, 1, and then -2. So with these two data that we have here, let's consider equation 2 and then do substitution. Okay, so let's continue from equation 2. Okay, so from equation 2, we have a multiplying x minus x naught, okay, plus b multiplying y minus y naught plus c multiplying z minus z naught equals 0. Okay, this is what you have now, which is the scalar equation of a plane. So now let's do the substitution. Okay, so our a here, that's from n. Our a will be equal to 8, and then b will be equal to -4, and then c will be equal to 4. Okay, and then we'll have x naught to be equal to 1, y naught to be equal to 1, and then z naught to be equal to -2. So now let's do the substitution. Okay, so we're going to have 8 multiplying x minus x naught, right? So that will be x minus 1, okay, plus b. And then we know b to be minus 4, so that will be minus 4 multiplying y minus what? Y naught, which is 1, okay, and then plus c, which is 4 multiplying z minus what? Z naught, which is minus 2. So I'm going to have plus 2 then. So all this should be equal to 0. So at this point here, we can simplify what you have here. So you're going to have 8x minus 8, and then minus 4y plus 4. Then you're going to have plus 4z plus 8. Okay, this should be equal to 0. So from what you have here, you have minus 18 and then plus 8 here. So they are going to cancel out. So let's write down what you have now. You're going to have 8x minus 4y plus 4z plus 4. Okay, this should be equal to 0. So this will be the equation of the plane passing through the point that was given. Thank you very much for watching this video. Please make sure you like and subscribe.